Hello my dear friends, welcome back. This will be the last theorem from chapter 6, triangles. So this is the last theorem which is important for the Nagaland Board of School Education examinations. So we have now done 3 theorems. If you remember, basic proportionality theorem, what happens to the ratio of the areas of similar triangles, then the Pythagoras theorem, and now we have this converse of Pythagoras theorem. So as the name suggests, it's going to be converse of Pythagoras theorem. Converse. Okay, what is converse? See, if you remember, what did we prove in the Pythagoras theorem? The Pythagoras theorem, what was proved was that there was a if we have a right angled triangle, then in that case the square of the longest side will be equal to the sum of the squares of the two shorter sides, and the angle opposite to the longest side is always that 90 degree. Now what will happen is just the reverse. That's why it's called converse. Now what will happen is they will be giving you a condition like this, such that there is a triangle in which the square of one side is equal to the sum of the squares of the two sides. Then if this happens, then it proves that the angle opposite to the 90 degree is a right angle. Once again, in Pythagoras theorem, what was given was that if you have a right angled triangle, then the square of the hypotenuse, the longest side, will be equal to the sum of the squares of the other two shorter sides. That was what was given. So this 90 degree was already given to you. Now we have to get this 90 degree. That is, if in a triangle the square of one side is equal to the sum of the squares of the other two sides, the shorter sides obviously, then the triangle is a right angled triangle, and the angle which is opposite to the longest side is or will be equal to 90 degree. That's what we are going to be proving with this converse of Pythagoras theorem. So as the statement gives us, that is, in a triangle, if the square of one side is equal to the sum of the squares of the other two shorter sides, then the angle opposite to the first side, longest side, is a right angle. Okay, so now let's see how do we prove. A triangle ABC such that AC square is equal to AB square plus BC square. That's already given, isn't it? Square of one side is equal to sum of the squares of the other two sides. To prove that triangle ABC is right angled at B, so we have assumed any triangle. So we have assumed triangle ABC such that AC square is equal to AB square plus BC square. You can use other names also, other letters also, no problem. So if that happens, then angle B is 90 degree. What do we do now for the proof is we construct a triangle PQR, an imaginary triangle, such that this side PQ will be equal to side AB, QR is equal to BC, and angle Q is equal to 90 degree. This is not there. Okay, this is what we have to prove. So we do not know anything about angle B. We are supposed to prove that angle B is 90 degree. So in this imaginary triangle, AB is equal to PQ, BC is equal to QR, and angle Q is equal to 90 degree. If we can prove that these two triangles are similar, maybe then in that case angle Q will be equal to angle B. In that case angle B will also be 90 degree. That's what we are going to be doing. Okay, so let's get straight to the proof. Since triangle PQR is right angled at Q, triangle PQR is right angled at Q, therefore this is by Pythagoras theorem, PR square will be equal to PQ square plus QR square. This will be by Pythagoras theorem. Let this be equation 1. But by construction, from our imaginary construction, what did we have? We had that PQ is equal to AB and QR is equal to BC. So therefore equation 1 becomes PR square equal to, can we write AB square plus BC square, because PQ is equal to AB and QR is equal to BC. Let this be equation 2. Okay. Also given that AB square plus BC square is equal to AC square. This is actually given in the question. We have used our own triangle. So from 2, what we can have is PR square is equal to AC square, isn't it? PR square is equal to AC square. Okay, so PR square equal to PQ, that's fine. Now by construction this happens. Now AB square plus BC square is equal to AC square. So in that case, square square if we cancel, if we take equate, then PR is equal to AC. Right, simple as that. Okay, so let's keep this condition now. So that means what have we got is that we have got that even PR is equal to AC. Now look at these two triangles. Remember that I told you that if you could prove that these two triangles are similar, and automatically angle Q and angle B becomes same and 90 degree, job done, right? That's what we're going to do now exactly. So now we'll now go for the proof that in triangle ABC and triangle PQR, what do we have? We have that AB is equal to PQ, right? BC is equal to QR. Now these two are from construction, from our construction, right? And then just now what did we prove? We proved that AC is equal to PR. That is proved. So by side congruency, triangle ABC not only similar, these two triangles become congruent also, congruent to PQR. So therefore in that case angle B becomes equal to angle Q, that is corresponding parts of congruent triangles. Remember that we have done it in class 9. But what did we assume? That angle Q is equal to 90 degrees. So therefore angle B is also equal to 90 degrees. That's it. Therefore hence triangle ABC is a right angled triangle where angle B is equal to 90 degrees. So it's a simple proof. You get this in the exams, you should be very happy. You can just write it down quickly and get some good marks. Simple as that. Okay, so it was not complicated at all, isn't it? Alright then, so that's it of the 4 theorems. Please do study well and all the best for your examinations. Till then, I'll see you with the next video with a new topic. Bye bye.